All right, hey, welcome everybody to CSE 224 Programming Tools. So this is the first lecture for the first week. Each week we will basically have two recorded lectures for you to watch before class. Since some people probably won't watch this before the first day of class, we're going to watch this as a group in class. So this first lecture is going to go over some basics. First, some basic details about the course itself, and then some information about Unix and Linux and what we're trying to do in this course, the idea of tools that we use for programming. And we'll go over a number of details, and then we're going to spend some time in class practicing with some of the things that we talk about. And this will be the general structure for the course. Will be to have you watch a video before a class that goes over some concept. For example, Git or make files or understanding pointers in C. And then we'll do some in-class activities in groups to let you work with the concepts that we've talked about. So this will be a very interactive course. It's a course that you're going to want to come to every class, and you're going to want to definitely watch the videos ahead of time so that you can fully participate in the classroom activities. Also, there's going to be a short quiz in the beginning of each class that will go over some of the details of the video just to double check that you actually did watch it. So one of the things I want to mention up front is the notion of a service learning project. And the service learning project, or SLP, is part of the entire year-long computer science sequence, beginning with this course. And the idea of the SLP is you're going to pick a project this quarter that you want to work on for the entire year. And it can be almost anything computer science, engineering related. It could be hardware, software, a mix, embedded systems. It could be learning some development environment. It could be creating your own video game. It could be getting a programmable microcontroller and using it to build some kind of device that you want. It's wide open. But the goal is to have you work on something which extends your knowledge, something which takes you outside the realm of what you're learning in your courses and gives you an opportunity to do some independent learning and then take what you've learned and apply it to some large-scale project. This is a really good part of your portfolio when you go on to, for example, applying for a job and people want to know, well, what sorts of things have you worked on? Typically, the service learning project can be one of those things that you can talk about passionately with great enthusiasm and describe, all the different pieces that were involved in coming up with this idea and making it work and testing it and presenting it and so on and so forth. And you get to present your progress in the SLP 3 times throughout the school year, ending with a large campus-wide presentation in June. So that's something that you're going to want to start thinking about, is what kind of project would you like to work on. And we can talk more about that when you've had a chance to think about it, and we can go over specific ideas and requirements and so on and so forth. So let me start the technical part of this with this notion of what certain things are. And definitions are important. They're not just for people who want to be picky and say, well, that's not what that term means. Definitions are really part of how we conceptualize. And I want to put people on a good footing with what the definitions are for different things. And for example, I hear people make comments sometimes like, I don't like editing with putty, right? And putty is not an editor. Or I don't know how to use C because I don't understand how to log into the CTEC server. Or I really don't like VI. I prefer the CTEC server. Or things like that, right? Where these sentences don't really make sense. So let me let me put down just a few terms and let's talk briefly about what the definitions are. The terms I want to discuss are a server, a client, which I'm also going to call a terminal program. There are other kinds of clients, but the main one we're going to be working with is a terminal program. An editor, a compiler, and an operating system. All right. So what is a server? ctech.clark.edu, the server that you used in CSE 121, that's an example of a server. We're going to use a different server in this class. It's called linux.engrcs.com. But a server is a machine that you can log into. Now, if you have a laptop or a desktop system that's running Linux, you turn it on, you boot it up, and now you can sit down and you can type and you can see responses coming on the display, right? That's a local machine that you have running, Linux or Windows. But we can also have a remote machine called a server that's also running Linux or Windows, and we can access it remotely and then pretend that, we're typing on our keyboard and we're getting stuff back from the display. We can pretend that the box that we're communicating with is sitting under our desk instead of, in a rack somewhere on the other side of the country. So a server is just a machine. It's a machine that we can communicate with and we can type things into, and it will send responses back to us. For example, ctech.clark.edu. A client or a terminal program is the piece of software we use to communicate with that machine. So for most of us, we use PuTTY, right? PuTTY is a program. It's not an operating system. It's not a language. It's not an editor. PuTTY is a program. It's a terminal program. In particular, it's a program that we would call a client. But it's just a program. Now, I can use PuTTY to connect to the CTech server. I can use it to connect to the server for this class. I can use it to connect to a different server at a different school. I can use it to connect to a machine at home. I can use it to connect to my cell phone or my Raspberry Pi on my 3D printer, right? PuTTY is just a communication program. Think of it as a big cable between your keyboard display and some remote system, right? It's just a way to take your keystrokes and send them to a machine and take the machine's output and send it back to you. So our picture might be, we have a server, which is a machine, and we use PuTTY to communicate. So here's our local computer, for example, a laptop. And this is the remote computer. And so we can go from our local computer through PuTTY and make connections to this remote computer. And we can send information back and forth. Now, what's running on this remote machine? Well, there's an operating system. And it could be running Windows, could be running Linux, could be running OS X, could be running, some other operating system. On CTech, it's running Linux. On our server for this class, it's running Linux. That's the main operating system we care about in this sequence, Linux, right? It's an operating system. It's the software running over here that responds to your commands. All right, so none of that has anything to do with editors or compilers. Right? So that's a machine. We can talk to it through PuTTY. There's other clients we can use. We'll mostly use a client called SSH. It's a secure shell login program. So there are numerous other things that we can do, but that's the basic setup. All right, so let's talk about editors. And to talk about editors, we need to talk about files. So what is a file? Well, a file is just a collection of information somewhere in our system. So we could have, a text file that has, human readable information in it, or we could have a binary file that has information that's intended to be read by the computer but not necessarily by us. So there's different kinds of files. An editor is something that we use to look at a text file. Alright, so I'm sitting here in a Linux machine, and I have a couple of files sitting in my current directory. One of them is called bio, and if I were to say cat, which is a command in Linux for looking at the contents of a file, if I cat bio, I can see it's a short biography on me. It says my name is Nick, I teach CSE 224. Now I can also look at this other file called haha, but if I cat that, I see a bunch of strange stuff. Right? And haha is an example of a binary file. It's containing information that's not really meant to be read by a human, but all of this stuff is meaningful to a computer. And in fact, if I run this program as a program, it prints out the current date and time. Whereas this other file, bio, is just, you know, a file containing some text information. So these are files, and if we have a text file like this, or a human readable file, or sometimes called a source file, we can edit it. And there's a number of different ways you can edit files. So if you don't know VI, or you're not comfortable with VI, right, we can edit this using something called nano. We can just say nano bio, and it brings up, you know, a simple kind of like notepad. We can move around with the arrow keys, and we can type, and we can backspace to delete, and so on and so forth. So I can say I like ice cream and add that to my bio. And down here at the bottom I can see, you know, the different ways that I do different things. For example, if I want to write this file out, I can hold down Control and press O. That's what the caret O means. And it'll say what file do I want to write to. The default is the same file, so I'll just hit Enter, and then I can exit by hitting Control X. And now if I cat my file bio, it's got this third line that says I like ice cream. Now the editor we want to use in this course is VI. VI is a much more powerful editor if you know how to use it. If you don't know how to use it, it's no better than WordPad or Notepad. It's just, you know, you move around with your arrow keys and you backspace and so on. But if you know how to use VI, you can do all sorts of things. For example, I can come over here and I can say, I want to shout, I like ice cream. And I can say I want to do that 100 times. And I can say I want to add some emphasis to the end of each of these lines. And now when I look at my bio, right, it's got my most important feature, which is I like ice cream. So we'll spend a unit talking about VI, and we'll learn how to do some of these things to make ourselves more efficient with editing. And part of the goals of this course is to become more efficient in our programming, which means becoming very comfortable with your environment, learning your tools. And this course is not about learning 5,000 different tools. This course is about learning a small set of tools, but becoming very, very good at using them. Right? This is you know, tool using 101. Get some collection of tools and get really good with them. And you know, we're not going to learn most of the things that these tools can do. Any tool, like for example, VI, there are thousands of things you can do inside VI. We're not going to learn thousands of things. We're going to learn, you know, 10 or 20 things, and we're going to use them a lot. We're going to get really good with them. So this is going to be a recurring theme. All right, so that's a little bit about what these things are, right? So the editor is what we use for modifying the contents of a text file, and then the compiler changes the text file into a binary file so that it can actually be run by the computer. So when we edit a program, what are we using? Are we using PuTTY? No. Are we using CTEC? No, we're using an editor like VI or Nano. We're using PuTTY to talk to that remote machine, and on that machine we're running a program like VI or Nano to edit a file on that machine. But PuTTY is not an editor. PuTTY is not an operating system. PuTTY is a conduit from our local machine to a remote one. Linux is not an editor. Linux is not a server. Linux is an operating system running on this particular machine. And an editor like VI is what we use to modify a text file. It's not the program itself that we're modifying. It's not the compiler that we're going to use. It's not the machine that we're logging into, right? VI, Nano, these are editors. They're programs for modifying text files. All right, so let's talk a little bit about why Linux. Linux is an operating system for programmers, right? Windows is not. You can do programming on Windows, but that's not the main purpose of Windows. Windows is designed to be an operating system for people who are not programmers to be able to run programs, to be able to run a browser, to be able to run Office products, to be able to play games, right? What we are interested in is developing programs and eventually, you know, working with what's going on inside the computer, studying the behavior of the operating system, modifying it, these things you'll do in other courses. Those are difficult to do on an operating system like Windows. They are very, very easy to do on an operating system like Linux. For one thing, Linux is open source. You can download the source code for the entire operating system. It's well documented, it's well supported, and it's very much tuned towards being able to customize. So Linux is the system we're going to be using throughout this entire 3-course sequence, and it's probably the system you'll use most often at a university when you transfer to continue your bachelor's degree. So why Linux? It's free, right? It's a free operating system, free as in no cost, and free as in you can do what you want with it. It's lightweight. You can get a very old laptop that, you know, will barely boot up anymore. Put Linux on it and it'll run like a champ, right? There are versions of Linux that are even more lightweight than the ones that we're going to be typically using that are geared towards running on very small machines. So it's a lightweight system. It's open, which means you can access it. It's highly customizable, right? You can tailor it to be exactly what you want it to be, which is important, because if you're going to be spending, you know, 20 hours a day in a Linux environment trying to do programming and debugging and development and things like that, right? You want to be in an environment that is comfortable. You don't want to be fighting your tools. If you want a number 2 pencil, you should have a number 2 pencil. You shouldn't have a indelible ink marker that you have to, you know, use whiteout to correct a mistake if you want a number 2 pencil, right? So Linux is very customizable. You can really set it up the way you want. It's a very logical operating system in the sense that it's mostly a bunch of simple commands that you get to put together in whatever way you want. So there's not a whole lot of figuring out, you know, is this really the way that Linux needs me to do something? It's mostly, this is what I want to do, this is how I'm going to do it. And for the most part, Linux will be agreeable with that. In that sense, it's very harmonious with C. A lot of the things that you do in C, especially more advanced C programming, has parallels to what you do in Linux, and vice versa. And basically, if you can imagine it, you can probably do it in Linux. But, you know, none of this is a benefit unless you're going to actually get in there and do some customizing and learn some of the tools and some of the fundamentals and spend enough time to say, you know what, I really wish that things were like this instead of that. And then go ahead and make things like this instead of that. If you're willing to do that, this is a really, really good environment to be working in. Now, if you have a machine already that boots up in Linux, that's great, right? That's your best option. But not everybody is going to have, you know, a spare machine kicking around that they can throw Linux on. So what I'm going to recommend to most students is that you use something called VirtualBox. And VirtualBox is just a program you run on your current computer, and it pretends that it's a new computer. And on this virtual computer, you can install your own version of Linux. I'm going to recommend Xubuntu version 22.04. honestly, you can get away with any version of Linux that you like, and you know, versions of Linux are like they're sacred beliefs to some people. They believe this is the only version of Linux people should use, or that is the only version, or this other version is horrible and nobody should use it. And I'm not intending to get into debates with people about what version of Unix to use. If you have no opinion, go with Xubuntu 22.04. If you love Arch or something else, you're welcome to do that, because Linux is pretty much Linux. But if you're starting off with this, right, and you use Xubuntu, you'll match what we're doing throughout the course, and it'll make things a little less confusing. So during class, part of the exercises we're going to do is to actually install VirtualBox and Xubuntu. If we're doing this in person, I'll have laptops for you to use. For the remote class, you'll be wanting to do this on your own machine. And this is you know, part of what we're going to do in the first class, and we'll get into details of it then. All right, next thing we want to talk about is accessing the server for this course. So the server we're going to use is called linux.engrcs.com. We're not using the CTEX server. Forget everything about the CTEX server. This is the machine we're using, and your username is totally different from CTEX server, right? You're forgetting about that machine. So you have a different username from what you had in CSE 121. So, for example, my name is Nick Macias. So my username is going to be my first initial followed by my last name, as it appears on Canvas. If you have a different name on Canvas, that's what you'll use to find your username. If you have hyphens in your last name and they appear on Canvas, you'll have hyphens in here. But it's just going to be first initial and last name. There's no punctuation, there's no numbers, right? Forget about CSE 121, forget about your CTEC login. This is your username. And then your password is your student ID followed by an underscore. So 10 characters, 9 digits, and an underscore. All right, let's go ahead and log into the Linux server. And I'm going to do this first through PuTTY, since that's probably what most people are going to use. So I'm going to bring up PuTTY, and I'm going to make sure my connection type says SSH. And then here I'm going to put in my username. Remember, that's first initial followed by last name, and then at linux.engrcs.com. And everything else should be fine as a default. So I'm going to do that, and it's going to ask me for my password. So I'm going to put in my student ID number followed by an underscore. And it's going to give me this following message, which says, "Warning, your password has expired. You must change your password now and log in again." All right. Now this is really, really small to read, so I'm just going to get out of here, and I'm going to show you a different way to log in. If you're running Linux, or if you've got Linux going on a VirtualBox, we can just say SSH, and then my username at linux.engrcs.com. All right, so now I'm logging in, and it says you're required to change your password immediately, change your password now and log in again. Okay, current password. If you mess up and you don't put in your correct password, it'll wait a few seconds and it'll say goodbye. So you do it again. Okay, I need to put in my current password, and then I need to put in a new password. And then I need to type the exact same password again. And if I mess that up and my passwords don't match, it's going to say goodbye. My password has not been changed, right? Look right here, password unchanged. So I'm going to try it again, right? Don't put in your new password here, because your password didn't get changed. Your password is still your student ID followed by an underscore. Now put in your new password, and put in your new password again, and it says password updated successfully, and it logs you out. So now you have to log back in again, but this time put in your new password. I've already got my password set up to share automatically. So I cheated and it logged me in right away. And we'll go over how to do that. But you would log back in and you would put in your new password, and then it'll take you to this prompt. It says, "Welcome to the Engineering Computer Science Linux server," and now you're good to go. All right, so that's logging in. So let's talk about a few basic commands in Linux, and that will do it for this first video. So we've talked about files, right? I can say ls, and I have no files right here. I can make a file called testing and just put some stuff in it. And I can make test2 and throw some things in there, and I can say, touch haha to make an empty file. So if I say ls, I can see a list of all my files in my current directory. So ls is a useful command, list your files. Most commands allow you to put modifiers on them, things called switches. And so, for example, if I say ls-l, it lists my files, but it gives me some additional information. It tells me when the file was created, for example, 16th September, or 10th September. It tells me how big the file is, how many characters are stored in there. Haha is empty. Who owns it? That's me. That's my username, and so on and so forth. And so there's different ways that we can modify these commands, and we'll be learning about those. And there's documentation built into Linux that tells you how to update these commands, how to modify them. All right. So one thing we might want to do is copy. So let me make a copy of test2. Let me just go ahead and sneak in here and edit this file. And I'll say this file is test2. So let's copy test2. I can say copy test2 to new file. And now I have a file called new file. And if I look at the contents of it, it's got the same contents as what test2 had. And I could copy a new file to be newer file. And now I've got another file called newer file. And if I cat newer file, it's another copy of test2. Alright, we can also rename files. The command for removing is actually move. So let's say I want to change haha to be something else. So I could say let's rename haha to empty file. Well, now if I look, there's no more haha, but there's a file called empty file. And if I do my ls-l, write my empty file, is still that file with 0 bytes in it. And, it was created at 4:06 p.m. when it was called haha. And it's also, empty file is created at 4:06 p.m. It's the same file. I just changed the name from haha to empty file. All right, if you want to delete a file, you can say rm for remove. So let's get rid of our empty file. And now when I look, there's no more empty file. And if I try to remove it again, it'll tell me it doesn't exist. If I remove test2, I've gotten rid of that test2 file. If I want to get rid of all the files in my directory, I can say rm star. And that's it. I just deleted all my files. All right, so that's the basic deal with files. The other thing we want to talk about is directories. And so, just like on other operating systems, right, there's a hierarchy of folders, if you like. There's my home directory. And I could have a folder under here called CSE224. I could have a folder called temp. And I could have a folder called fun. And maybe under CSE224, I'm going to have a folder called homework 1 and a folder called homework 2. So you use folders to organize your work, basically. So if I want to know what directory I'm currently in, the command is pwd, print working directory. Working directory means your current directory. So pwd, hey, my current directory is /home/nmacias. And each of you, your home directory, what you get when you say pwd will be /home / your username, first initial, last name. I can make a new directory. I can say make dir CSE224. And now if I look, there's a 224 directory. How do I know it's a directory? If I say ls-l, there's a little d in the beginning here. That's D for directory. Whereas for these files, that first character was just a dash, meaning this is just a plain old file. I can make a directory called temp, and I can make a directory called fun. Now I've got 3 directories. Alright, so pwd tells you what directory you're in. cd is for changing your directory. If I say cd CSE224, and now I print my working directory, hey, I'm in a subdirectory, CSE224, underneath nMacias. I can make dir homework 1, I can make dir homework 2, and in my 224 directory, I have 2 more directories. I can go into homework 1, and now if I print directory, I'm under my home directory nMacias, CSE224, homework 1. And maybe I'll start, a main program in here. So under CSE224 homework 1, I've got a file called main.c. Alright, if I want to go back home, I can just say cd, and now I'm back to my home directory. And all I have under here are my 3 subdirectories. If I cd into CSE224, there's my 2 homework directories. If I go into homework 2, that's empty. Suppose I want to go into homework 1. I need to go up 1 level and back down. I can move up 1 level by saying cd ... And now I'm in CSE224, and now I can go into homework 1 and I can see my main program. I could also cd ... So the first ... will take me to CSE224, the second will take me back to nMacias. And so that did the same thing as if I had just said cd. cd always takes you home. So I can also say, cd CSE224 / homework 1. And that'll take me directly into this subdirectory and into this deeper subdirectory. So play around with make dir cd pwd and this idea of ... We want to be able to move around directories efficiently. And it's a really basic thing, but it is super important because you're going to be making a lot of files in this course and other courses, and you don't want to just have them all sitting in one directory. You want to organize things, right? It's like having a filing cabinet instead of just a big box that you throw everything into. So we want to get really good at organizing our work, our files and programs and so on. And so being able to make directories, move around directories, those are all essential skills. And we'll be doing some exercises with that. All right. The last thing I want to go over is this notion of what is a program. And programs, they're just files. They're just executable files. So I'm back in my home directory. I can use the ls command to see what's in my current directory, but I can also say ls and put in the name of a subdirectory, and it'll show me what's in CSE224. Or I can say ls CSE224 / homework 1, and I can see my main.c. And these are called relative paths because I'm saying starting in my current directory, right, which is nMacias, find a subdirectory named CSE224, and then in there find another subdirectory, and so on. So this specification for a directory is relative to where I am right now. Now if I go into my fun directory and I say ls CSE224 homework 1, it's not going to know what I mean because there is no CSE224 under my current directory. But I could say ls / home / nMacias / CSE224 / homework 1, Oh, that's not what I wanted to do. I can say ls/home/n/macias/cse224/homework1, and it will show me that file, even though I'm currently sitting in my fun directory, which has no subdirectories. So the difference is I've got this slash in the beginning. This slash makes this what's called an absolute path. And it's saying, hey, starting at slash, which is the root directory, the top of the whole hierarchy, find a directory called home, and then under there, find a directory called nmacias and CSE224 and homework1. And so the way our file system is actually laid out is there's a root directory called slash, and underneath that there's a home, and underneath that there's an nmacias, and underneath that there's a CSE224, and underneath that is a homework1. There's also a /home/ and there's other users. And under slash there's also other directories, for example, etc and bin and usr. So there's this whole hierarchy of files. And if I say ls/, I can see all the files sitting in the top level directory. And I could also cd to slash, so that I'm sitting in that directory, and just say ls and see exactly the same information. But usually we don't want to have to change directories just to look at files. So sitting in my home directory, I can say ls/ and see what's in that directory. Well, there's a directory right here in the beginning called bin, and if we look at /bin, we see a whole bunch of files in there, including things like GCC, which you may remember is the C compiler. There's also a file in here called ls. That's the program we're using to list files. And there's a file called du for looking at disk usage, and rcp for remote copy, and lsmod, and all these other files. These are all programs. So if I say ls-l/bin/ls, that is the ls program. That's the program that runs when I say ls. And it's exactly the same thing as saying /bin/ls. Shows me what my current directory looks like. Alright, that's a ton of information. Enough talking. Let's go ahead and start playing with these things in groups and get more familiar with some of these concepts.